Okay, so this is a no-nonsense guide on how to do lerping in Unity. Playing on the screen right now is an example scene that I've made, and you can see a lot of things lerping. There's positions lerping, as well as being able to lerp the scale of UI elements, the colour of the lights on the scene. You can also see how animation curves are used, as apart from the second cube, each cube takes 2 seconds to cross the plane, although their animations gives vastly different effects. And here's an example where lerping was used to turn down the volume of a background audio whilst a voice line plays. This was used in one of the games that I've worked on recently, so this solution is definitely battle tested. The femur is the biggest bone in your body. It goes from your hip to your knee. So I'll quickly go over what lerping is, then I'll explain the architecture of the system we're going to create, and then we'll get on to creating it. So what is lerping? Well, lerping allows you to calculate a value from a start value, end value, and t value. T value is between 0 and 1, and it basically tells the lerp how close to the target value you should return. This graph might help it here. On the y-axis is our start and end value, and then on the x-axis is our t value. You see, if we start at 0 and end at 1, a t-value of 0.5 will give us 0.5, a t-value of 0.25 will give us 0.25, and a t-value of 0.1 will give us 0.1. Now we can use this by gradually increasing our t-value over time, which will allow our value to gradually change from a start value to an end value over time. At the bottom of our abstraction hierarchy, we have a lerp package. A lerp package encapsulates data needed to interpolate from a start value to a target value over time. Above that, we have a lerp package processor. A lerp package processor will take in a bunch of lerp packages and process them. Then we have a global lerp processor. This is globally accessible and allows us to input our lerp packages to one centralized processor. Then at the top of our abstraction hierarchy, we've got some extension methods, which will make it really easy to start one of these lerp over times. Once the system is complete, you'll be able to use a snippet of code like this one to move an object from one position to another over time. So starting off in our scripts folder, we're going to make 4 new scripts: lerp package processor, global processor, and type lerp extensions. So inside of this script, we're going to have the base abstract class of a lerp package, and then we're going to have all of our specific lerp packages that implement our lerp package base class. So examples of these specific classes would be a float lerp package, or a vector 2, 3, or 4 lerp package, or a color lerp package, for example. So the first thing we'll do is we'll delete this lerp package class. Now we'll define 2 delegates which will be used within the lerp package class. The first one being lerp step, and the second one being a package processed delegate. Okay, so now we can create our lerp package class, which will be a public abstract class. Inside of this class, we're going to have some attributes, some methods, some abstract attributes, and some abstract methods. Let's start with the attributes. We're going to have a final callback of type package processed, which will hold a lambda function given to us by the user, which fits into this package processed. Next, we'll define some variables that are to do with the actual lerping process. Okay, now let's define our abstract attributes. We'll define a start and target attribute, each with their own auto-implemented getter and setter. Now we'll define our methods of the class, and I'll also define the constructor. Finally, we'll add our abstract methods. Okay, and that's just done for now for the lerp package. We'll move on to the lerp package processor. First of all, we want to remove the inheritance to mono behavior, as this isn't going to be a component which is attached to an object in our scene. This class will have one attribute, which will be a list of lerp packages. We need a method to add packages to this list, and we need a method to loop through the list and update each package. Let's start with adding a package to the list. Do our function for updating all the packages. We're going to loop from the end to the start of our package list and update each package. So for each package in the list, we call the process package function on that package, passing in the package itself as well as its index. So now we'll define the process package function. So the first thing we need to do is update the current lerp percentage. We'll increase the package's elapsed time by delta time. Now we can use this new updated elapsed time to find the package's current percentage. This will do linear interpolation, but we can also use the package's animation graph if we want to have different types of interpolation, say ease in, ease out. So we'll say, finally we'll clamp current to be between 0 and 1. Now we'll call the package's run step callback function. Now we need to remove the package if it's finished lerping. We'll do this by checking if the package's current value is equal to 1, and if it is, then it means it's complete and it needs to be removed from the list. Okay, now this is a little bit messy. It would be better if we could collapse this down into its own functions. So we'll extract all of this using our extract method function. You can do the same on Visual Studio. The keybind is Ctrl+R, Ctrl+M. This part updates our current lerp percentage, so we'll extract this as a method as well. There we go. And now finally we'll extract this into a method which will be called remove package at index if completed. Just to tidy this up a little bit, we'll move this function down to the bottom. And that's the lerp package processor done. Time to do the global lerp processor. So this class will inherit from mono behavior, as we'll need it to be attached to a game object in order to hook up to Unity's update function. And this class will use some singleton type design patterns. So you'll see a lot of static things, and if you're a beginner, don't worry, it's nowhere near as scary as it might look. First of all, we're going to make a static attribute which holds a reference to the global processor handler that's in our scene. We can call this instance or reference, whatever we want really. We're also going to make some default animation curves that can be used. These default animation curves will be a linear curve and an ease in out curve. These curves will start at 0 value and 0 time and end at 1 time and 1 value. Now we'll make an attribute that will belong to an instance of this class, and that attribute will hold the lerp processor. Now we'll make a function to add a lerp package to this lerp processor. This function will use lazy instantiation, meaning if instance is null, it will create an instance and then add the package to that new instance. If instance isn't null, then it will just add the package straight in. So here you can see we're trying to add the package to the processor, but if this instance doesn't exist, a null reference exception will be thrown, which we can catch and handle appropriately. To handle it, we'll create a new object to be placed into our Unity scene, and we'll attach a global lerp processor component to it, and then we'll add the package just like we did up here. Okay, there we go. So now we've exposed a method which will allow us to add packages to the global lerp processor. Because we're using the singleton design pattern, we'll put some code in the awake function to enforce there only being one instance of this class at any time. Awake will be called when a new instance of the global lerp processor is created. When this instance is created, the instance static variable may be null. If it is, then that's great. We'll set the instance created to the instance here. If it's not null, then this means this isn't the first global lerp processor to be made, and therefore we'll have to delete this. Now we'll add some code to ensure the lerping system works after changing scenes. Finally, we'll add code into the update function. Okay, so now we'll go back to our lerp package script, and we'll create a float lerp package we'll inherit from our lerp package class. Let's define our attributes. Now we'll override the start and target attributes. The getter will return this.start, but the float version of this.start that we defined up here, and the setter will set this.start to equal value, but first we'll cast value to a float. Same thing for target. Now we'll define our constructor for our float lerp package. We need to call the base class constructor, and we'll pass in the final callback, time to lerp, and animation curve. And now inside of this constructor, we'll set things that are unique to the float lerp package class, like the start and target. We'll also set the step callback, and that's it. Finally, we'll add our override methods from the base class. So this is where the lerp calculation is done. For a float, we use mathf.lerp. If this was a vector 3, we could use vector3.lerp. Vector 2 has a .lerp, so does color as well. And basically anything with a function to lerp it can be made into a lerp package. So this system by itself now works. Finally, we'll complete the type lerp extensions, allowing us to create new lerp packages in a more user-friendly and readable way. So first of all, we don't want this to be a mono behavior. We want this to be a static class. Now inside of here, we can define lerp2 method for each of our different lerp package types. So we'll do one for floats. We'll say public static void lerp2. We'll give a value. We'll give a target and a time to take. Okay, so first of all, we're going to check if update callback, package processed, and animation curve are null. If they are null, we'll give them some default values. In this case, we'll give a default lambda function to call. Give a linear curve by default. And now we can add our lerp package onto the global lerp processor. Okay, awesome. Let's test if the system works. We'll make a new object in our scene called test object, and we'll make a new script just called lerp test. Inside of here, we could either make a float variable, and then in the start function call variable.lerp2, or we could literally just give a float number and say .lerp2. We might want to lerp this to 20. We might want it to take 1.5 seconds. So we can supply a lambda function on what to do every update, and we do this by saying value, and then here's our lambda function, and then you write your code in here. For now, we'll just debug log value. We can also supply a finished callback, which takes in a package. And here we can just debug.log lerp complete. And if we wanted to, we could supply our own animation curve. For this, we'll make a private animation curve called anim curve, and we'll make it serialized. And inside of here, we'll pass in our anim curve. So if we go back to the editor and we have a look at our test object, we can see there's an animation curve here. We can say use this type of animation curve, and we can adjust it as we need. Let's say we want to do something funky like this. Okay, so when we run this, we'll see lerp from 0 to 20 using our animation curve. There we go. If we want that to be a bit slower, we can. We can go to our lerp test function, and we can reduce this time. Let's say that we want this to be 10 seconds to see things more clearly. And you'll see following the curve, it will go up all the way to completion, then it will come down, then it will go back up again. There we go. Or if we're not too bothered about what to do every frame, what to do on the callback, or if we're not bothered about it being linear and having control over the graph, we can always delete this and just call the start, the target, and how long we want it to take. And now this will linearly interpolate from our start to our target over the course of 5 seconds. This is how to add new package types to the system. You can either do it at the bottom of the lerp package file, or you can make a new file. For example, I'll call this one vector3 lerp package. And so we'll go back to our float lerp package, and we'll just copy the entire class, and we'll paste it in here. So now I'll go through this code and pretty much anywhere that I see floats, I'll replace it with vector 3, apart from the time to lerp. Or you could use a find and replace operation. And then finally, instead of having a mathf.lerp, I'll replace this with a vector3.lerp. Now we'll just add an extra extension method for doing the lerping. So we'll copy this and paste it here, and then again, replace anywhere I see a float with vector 3, apart from the time to lerp. Okay, and there we go. That's how you can easily add new types to the lerping system. And so if I wanted to use this at all, I would simply call the same lerp2 function, passing in a target and a time to take, and this would work exactly the same. It's also worth noting, if you wanted to do a slurp package, you could just replace the vector3.lerp with a vector3.slurp, and you could do that very easily. You'd also have to make a slurp2 method in the extension methods class. I'll also leave a link to a GitHub repository with all of the code. Thank you so much for watching. If this video has been useful or you've learnt anything, please leave a like, it'll be greatly appreciated, and a little comment letting me know what you think of the tutorial, and feel free to subscribe. With that being said, have a great day, good luck on any projects you're working on, and yeah, okay, bye.